and you had to specify, you had to determine what lines needed to be changed if you had a different initial value problem. So in other words, here's your function, right? This is, you got this function here, sine of x. Well, first of all, one of the things with MATLAB is that the indexing starts from 0 and it starts from 1. Excuse me. The indexing in MATLAB starts from 1 and not 0. So when we do Euler's method by hand, you know, we start out with our initial values x of 0 and x of 1, right? In other words, that's what we've been doing. But MATLAB calls the initial values x1 and x and y1. So for this example, right, if we have to if we hand calculate, we have we go from x0, y0, x1, y1, and so on using Euler's method. But MATLAB would calculate the same 6 points, but they would be labeled as x1, y1, x2, y2, up to x6, y6. All right. So that's the difference, because MATLAB can't deal with 0 indices. Some computers do. But MATLAB doesn't deal with 0 indices. So you have to start from 1. So in other words, this x of 1 equals 0. This really means you would write this, if you had an x of 0 equal to 0, you'd write this as x of 0 equal to 0. This corresponds to y of 0 is equal to -2. Okay. So if you had this code, right, the lines that you would have to change, lines 4, lines 5, lines 8, because 8 is the function. Okay. In other words, I want to show both at once. Let me let's see. I guess maybe this is the last thing we're going to do today. All right, I'm going to change here because I want to be able to write. Okay. Not that clear, is it? I assume everybody's seeing my Euler's method for initial value problem, right? Okay. So so here's what I want to point out, that if I had a differential equation like this, let's see.
We can't see your screen.
What's that? You're not. I stopped sharing, right? Let's see. I'm not sure. You're seeing.
Yeah, we can.
You see. You're seeing. You're seeing a piece of paper now, right?
I can.
And we only see you.
Yeah. Okay. Well, this is what I had up on the screen before. It's not as clear as I like it to be, but what I want to point out is that if you had a differential equation, let's say was I don't know, where well this is actually solving this differential equation. It's solving the sine. Let me sine of x minus, I guess I'll put it down here, 3x times y cubed, right? That's what it's solving this differential equation for this initial condition. Y of 0 is equal to minus 2. Oh, excuse me, it's not. It's y. Yeah, x is equal to 0. So, okay. So we're solving this differential equation here, right? So if we had a different one, right? And if we were starting from an initial condition, right? We're starting from an initial condition where we had 0, we wouldn't need to change this line, right? But I'm going to give you on the exam, I'm going to give you a problem that you have to do by hand, but you can check your result. It'll be a simple problem you can do by hand, but you can also check your result before you hand it in if you want by using this script. Okay. And now see here, the step size is 0.2. So you would want to change the steps. If you wanted a different step size, you'd have to change that. But I wouldn't, yeah, then that's going to change the iterations too, though. Okay. So the important thing is that that the lines you have to change, right, would be 4, 5, right? You'd have to change 8. See, because 8 is actually line 8 is the is where the function is given, right? Line 8 is where we have this. That's what line 8 is. Line 8, we have this. So whatever you have here, you would have to put here, right? And in this case here, we have what I have down, what I wrote down here. And here you would have to, you'd have to change this too here, right? You'd have to change this too. And no, you don't have to change that. What am I doing? You'd have to change this. This is fine. You don't need to change that, right? So you'd have to change line 25, right? You'd have to change line 8, right? You have to change line 5. And line 4, you'd only have to change line 4 if you weren't starting. In other words, if this wasn't 0, if you weren't starting at x is equal to 0. Many times when you solve problems, you're starting from x is equal to 0. So you wouldn't have to change that. Okay. So so note that if x is equal to 0, you don't have to change line 4. But that was a problem that was given on the final exam. That was a department problem where where you were given the script and you had to determine that if you had a different function, what lines would you need to change? And I don't know, I actually thought it was too easy of a problem, being I went over the script too. During, we would go over the script before class, all right? But the students, once again, the students had to say what lines you need to change if you had a different function, different initial condition. And the answer was just 4, 5, 8, and 25. Those are the lines you have to change. I think it's pretty obvious, right? If you understand all this question, and none of that, but the code here is documented. All right. Let's see. All right. Trying to see now. And now I'm going to go back to here. Well, it looks so now you're looking at the Blackboard again. I hope. Let's see if there's anything else I want to do. Okay, so here's okay. I actually gave this. Take a look at this problem. Okay, you're going to have a problem exactly like this on the exam, on the first exam. Matter of fact, I don't give the same problems all the time, but very, very similar problems. This is the exact problem I gave the last time I taught this course on the exam, which you're seeing here right now. And I want everybody to get it right this time. I would say 98% of the students got it right. I had 2 classes, so I had over 50, I think I had over 56 students, but I'd say 98% of them got this right. Where they failed is that, where students made a mistake and I probably took off 2 points or something. They went one too far. Okay. So be careful when, Y5, right? Y5 is actually calculated when you got X4, right? You follow what I'm saying here? Like this is Y5. It was calculated with X4. So the Y5 is this number here, right? Many times students will calculate this and then give me this for Y5. You follow what I'm saying? They go one too many. So yeah, just be careful with that. Okay, we still got 15 minutes. I don't know if I should
Could you do an Euler's problem by hand? I mean, I think
yeah,
I think I get it, but
let's-
just if we have time.
No. We could do this problem by hand. Let's see how I can do this. We got 15 minutes. This is all I was planning on doing. So, all right. Let's see. The thing is, we need a calculator, but all right. Give me a second here. I gotta find something. Yeah, we got time to do one by hand. Come on. Where is- I can't find it. I think we could do a couple of iterations. Let's see what. I'm missing. Trying to find something. Understand this. can't find my original, yes. Let's try this here. See if this works. Okay, could you see what I'm writing? If I, let's say I have this differential equation here. Okay, are you seeing me writing?
No, professor.
No?
No.
You're not see?
Yeah, we can see it.
Okay. Okay, you're not, all right. So in this problem here, we'd have x of 0. Let's say we start out at 0. X of 0 is equal to 0.0. Y of 0 is equal to 2.0. And then y of 1 would be equal to, I put in the 2, right? Remember now, the formula, yeah, I put in the 2.0, right? Plus 0 squared plus 2 squared is equal to 2.4, right? Oh, I forgot the point. I forgot the H. Right? The H, which is make it 0.1. And this becomes 2.4. Okay, so that's my Y1. All right, that's my Y1. Now, and that's for X0. Now, if I have X1 is equal to 0.1, then Y1 is equal to 2.4, right? I just calculated 2.4. So then Y2 now, Y2 is 2.4 plus, now, remember now, the formula here is Y, Y to the N plus 1, Y to the N plus, in this case here, it's X squared plus Y squared times H, right? Okay, so, okay, so now I got X squared here. So this is 0.1 squared plus 2.4 squared times 0.1. And this number turns out to be 2.977. Okay. So now I get X sub 2 is equal to 0.2. Y sub 2 is equal to 2.977. That's what I just calculated. So now Y sub 3, I put in now the 2.977, and you should carry these out to 4 decimal places. So then Y sub 3 is 2.977. Now I got the 0.2 here, so there's 0.2 squared plus 2.977 squared, and then times 0.1, and now I get 3.8673. I'll just do one more. So now X is equal to 0.3, right? So now Y sub 3, Y sub 3 is going to be equal to, wait a second. This is Y, 1, 2, 3. Yeah, right. Okay. Yeah, so Y sub 3 is equal to Y sub 4, which is equal to 3.8673, right? I'm just putting this number in here now. And now this is 0.2, 0.3 squared plus 3.8 squared times 0.1. And then, so this turns out to be Y sub 4 is equal to Y sub 4 is equal to 5.3719. All right, so this would actually be, this would correspond to this number here would correspond to x of 4. In other words, this would be, I could do one more. Right? This is actually, yeah, this is x of 4 is equal to that. Where you use, what? No, I got it. No, this is x. This is 3. It's always one less. If I'm looking at y sub 4, it's one less here. See, let me go back to this. See, I'm just copying what I is all we're going to do for today. I'm just copying what I have here. All right, now you're looking at the blackboard. Now you're looking at the blackboard. So you see, the point I want to make is that when you calculate the x is equal to 0.4, right? That's actually giving you y is equal to 5. Okay, that's what I'm trying to show you here. Right, students just have a tendency to go one more than, like I said, and I gave this previously. They got it right, but a couple of students just went one too many far, one iteration too far. And you can see that, you know, if you go through what I did with, I assume everybody can still see. Okay, like here, you know, you only do like the 9 iterations. See here, like to get the answer in the books. So you just go out x, when you're looking at the x.145, that's actually giving you the 1 and y is equal to 1.5. Okay, so just don't make that mistake. I hope it's clear. I guess we did use all the time today, which is fine. But I got, the good thing is I got done everything I wanted to get done today. So piece of cake, right? Anybody have any questions? All right, I want to see if you're paying attention. I just got one more question, see if you're paying attention. Why did the students eat their differential equations homework?
Why, Professor?
Because the professor said it was a piece of cake.
Ha.
You know, I do give extra credit when you laugh at my jokes.
Ha ha ha.
Ha ha ha.
Okay, nobody liked it, huh? Okay. All right. One other. What do you do if you're in the classroom and you're feeling very cold? You're back in the classroom. You're at Montgomery College, and you're feeling very cold. What should you do?
What?
Go sit in the corner. It's 90 degrees there.
Okay, I like
that was
that one.
better.
Oh,
That
yeah.
was better. I like that one.
That's a good one.
All right. Well, that's it for today. I'll stay on for a couple. I'll stay on if anybody has any questions.
Professor,
Yes.
I have a question. I want to talk with you about exam.
What's it? Repeat that again, please.
I want to talk about this week's exam.
Okay. What about?
Can I do it early? Can I take exam in Wednesday?
You want to take the exam Wednesday instead of Thursday? Or you not?
Yes. Yes.
Yeah, I guess you can.
And I will submit Thursday before class.
Excuse me, say that again.
So you say if I start with exam Wednesday, so I can submit the next day or before class?
Yeah. I mean, the plan is that you take I give everybody the exam on Thursday. And then they submit it on Friday, but you would take it on Wednesday and submit it on Thursday night.
Just it. Okay, I got it.
Okay.
Thank you, Professor.
Okay,
Professor?
yes.
First of all, could I also do that?
You want to take it on Wednesday instead of Thursday?
Yeah, I'm going out of town on Thursday and I was planning on leaving right after class, so it'll probably be better if I could take it on Wednesday.
Okay, all right.
And also,
Okay, I guess I should have told her, send me an email.
okay,
So, okay.
I'll do that.
Okay,
And the second of the two first homework sets, I requested an extension on WebAssign because it was a little longer than I thought it would be, and I didn't finish it this weekend. So I'll have it into you by midnight tonight, but I don't know if you saw it because I requested the extension on WebAssign.
okay. Did you send me an email or did it on WebAssign?
I just did it on WebAssign. I'm going to send you an email about this and the exam after class.
Okay, all right,
Thank you.
okay.
And Professor, just piggybacking into what one of my classmates said. So if, for example, I take my exam on Thursday, so it's going to be due on Friday at 11:59, the latest.
Yes,
All right. And then one more question. I recently changed calculators, and on my previous, I had a TI 83 plus. I also had the Euler's method program installed into it.
okay.
So should I do the same for my new calculator that I just got? It's a TI 84 plus.